Thank you for joining us for this talk on a new feature in Graph Network in version 12. So the version 12 release essentially focus on improving the existing functionality as well as providing a better usability. So what I will do for the next couple of minutes, I will essentially show you some of the key new feature. And one of them is our visualization, where we essentially improve or modernize all the existing functions, graph plot and related functions. And after that, I will talk about property inheritance, which was a highly requested feature. And I will end by showing you some new feature as well as the integration in the existing Wolfram language, as well as other new functionality we can get from new area like convex optimization we have in the system, and how you can actually use it to solve your graph problem. Okay, so let us start with the visualization. So in this release, essentially we focus on modernizing all the graph plot 3D, layer graph plot, and tree plot, to essentially provide them the same default style like graph, as well as all the feature we have in graph, plot themes and layout. So if now you just evaluate a graph using graph plot, you get the new layout and the same look and feel of graphs. But also what we try to do is also provide backward compatibility. So if you really want to keep the old look and just for some reason or your application you just want to preserve it, you can still just apply a PlotTheme classic and then you get the old look. So let's a little bit dig in details what we actually provided. So here is the reference page of graph plot, right? So one key thing is that you can give him a graph object, and we can actually generate you the plot, which in this case will be a graphic or a graphic 3D object, depending of the function you are using. But also you can provide him all the argument and specification you have in graph. So you can give him a list of edges, edges with wrapper or vertex with wrapper, or you can even give him, in this case, an adjacency matrix, and it will automatically actually generate you a graph with the appropriate layout, right? And also you can provide in all the option of graphs. So we make sure to actually fully integrate or actually make both of those universe now compatible, graph plot and graphs. And I'm sure some of you probably ask, why do we need actually again graph plot if we already have graph which auto visualize? I mean, there is a lot of advantage of having graph plot, which is a plot function. So first, you return you a graphic instead of graph, where you actually have a graph object. That's one of the key things. And also from a graph object, which maybe auto visualize or maybe just return you a summary blob, you can actually apply graph plot and change the option. So it provides you all that flexibility of just changing the option without having to reconstruct automatically the graph. And we hope actually in future that we will actually improve or add more new feature to graph plot to allow you to display large graph. You won't be able just to display in a piece of paper or from the direct auto visualization of graph. So in long term, there is a plan for graph plot, and it will be quite useful. And from already versions 12, we see already a lot of advantage and all the flexibility it provides. So on top of that specification and that extension of the argument, we added the support of the PlotTheme, right? Same as in graph. So you can use all the standard PlotTheme from business to different warm color, and you get a new look for your graph or your plot. essentially. But also what we did is we actually decided to even add a little bit more new functionality. So in this case, we actually added a new layout for graph plot and automatically for graph 2. And that layout is the gravity embedding. And essentially, it is based on the Spring embedding with, the fact or the main difference is that, here we, minimize the energy, but with a, central point with high gravity in the middle. So a kind of central attractive force. And we call it gravity because you can just think about it as, it's a gravitational force applying to all those vertex, which are kind of, point mass, and the edges are springs. So from a layout like this, you can actually get a nice layout like that. And in this case, we automatically apply a custom edge function here, a curve arc, as you see. So it's kind of a quite, nice and useful layout. And we hope in future version we'll add more layout, which will kind of help you visualize your graph in a nice way. One additional thing we also did in this release is that we added a new PlotTheme, and we call it, index labeled. And it's quite useful because it's a kind of a single color design for labels, and quite, useful for publication, where you just want, a black and white type color. So in this case, I take a complete graph and I just apply PlotTheme index labeled, and then you get that. Right. And you can do essentially the same with graph plot, layer graph plot, tree plot, and graph plot 3Ds. So now we have a kind of a uniform framework, and they all share the same functionality as well as all the new ones. Okay, so this is kind of what we introduce in terms of visualization. So we enhance or we modernize graph plot, enhance the argument, the input and argument it can handle, and we introduce new layout and plot themes. So it's kind of in the brief summary for that. So now let's look at property inheritance. Essentially, since the release of Graph and Network, I believe it was in version 10, if I'm right, version 10 or 9, one requested feature was the inheritance of properties. So when you have a graph, which for example have weight, and you apply a function on it, you may expect, for example, the new resulting graph to actually carry those weights, right? As well as any other feature. So at the time of the release, we kind of, waited to see, the feedback from user and, how they will use graph functionality before we actually went in that direction. Because the inheritance of property or that automation, it's a little bit quite complex, especially in terms of, the user expectation. One basic example is if you generate a graph and decide to automatically compute the coordinates, especially for large graph, it can be expensive, and maybe the user doesn't want to actually manipulate, or he doesn't actually want to look at the layout. So after getting all the feedback and the comment from user, we kind of think that in this release, we had a good view of how people want to use or want the inheritance of properties. So here I gave you a basic example. So I construct a Peterson graph here with a nice layout. You can just directly apply a fine spamming tree on it. And you see that fine spamming tree here generates you a new graph where it actually preserves almost everything, from the coordinate of the vertices to the color of the vertices, the label, and the shape, right? And also implicitly, it also have the weight automatically stored. So this kind of inheritance of property. And so what we did essentially, we look at each function and essentially each operation we have in graph, and look at what will be the expected behavior and what property we should carry, which can be from label, weight to coordinate. So, and this is kind of the full collection of the function we currently support. There may be a few other where it's slightly a little bit ambiguous what we should do there, but we hope in the coming version we'll actually resolve all that. Especially that some of them may require some more extensible language specification for the property. And we are still trying to evaluate on that if we need to introduce a whole arithmetic on that or not. But now let's first just look at the general idea of that specification or that small language for property inheritance. So when you have a graph like this, so we have a nice styled graph like there, let's just compute the subgraph using those vertices. So there you have the subgraph where we automatically carry those properties. So the color of the vertex and edge and the coordinate as well as anything else behind. So one of the first things in that language specification is that you can apply or you can request to carry property globally. So in this case, you set, property goes to none. So if you do that, in this case, we don't carry actually, the layout or any other property. So we kind of completely disregard them. So that's kind of the global way to do that. Or you can just say inherited, and then you get essentially or exactly the layout above, right? And that's happening because the default option of property in this case is automatic. So when it's automatic, we figure out what should be the most appropriate thing. So if you don't want the property, you just say none, and you have that. And for sure, you will notice a difference in terms of performance because we actually have to compute those properties, especially if it involves, layout, where we actually need to compute a full layout and carry those properties. So this is kind of the global specification. But now you can come and do a more custom, specification, and decide to inherit property on, all the vertex, all the vertex coordinate, or all the edge and such. So you can actually specify at which level you want that. So in this case, we take the subgraph and we tell him, well, we want just to carry edge style as well as vertex coordinate. So when you evaluate it, there you see the key difference between that one. Okay, so let me erase this one. That one and this one. So here we carry actually the coordinate. So you see the layout as well as the color of the edges. But you can also go one level below and actually do that per vertex or per edge, essentially. So in this case, we decide, well, generate the graph and only carry the property of the edge, 3 goes to 2, and maybe the vertex coordinate, right? And any other edge, set them to red. So you actually see that here. So, and as we do the computation, if one of the specification is not used, we disregard it and such. So we actually do that whole analysis and parsing of your options. So that's kind of a nice language, flexible enough, not too much in detail, but can allow you to do your operations. Okay. So let me just look in the Twitch here if we have a question before I move on to other feature. So first I have a question here. It would be more useful to separate styling from layout, vertex computation, though don't change the edge style for the graph layout. Well, essentially, as I showed in the specification of the inheritance, you have a full control of the layout as well as the edges, and we handle them separately. Right? So, and you have all that more uniformly, right? So, well, I believe the question was about the graph embedding. Well, in terms of graph embedding, what we decided to do essentially is to provide you a nice layout for your graph. So you still have the flexibility to, modify it, specify it, and turn off some of the features, right? So what we hope is that in the most default case, somebody get actually something which is nice visually. For sure, if you are trying to apply graph embedding to a really large network or some random network, some of those features we turn on by default are not the best, right? But we just hope that for small or medium-sized graph, they are the most, visually appealing, right? So, but you still have that flexibility to actually turn off those features. Okay, so let's move on to the next key set of feature, which in this case are the new functionality. So in this release, we added 2 new predicates. So vertex weighted graph and edge weighted graph. And those were actually user requested functionality to be able to check if a graph have weight on its vertices or if a graph have weight on its edges. So in this case, if you apply it to a complete graph with vertex weight, you get that. And if you apply it edge weighted graph to a complete graph with edge weight, you get true, right? And also we still have the weighted graph queue general function. We check for both cases if your graph have weighted on vertices or on edges. Okay. So as I pointed out before, we for the last couple of releases, we focus on actually integrating graph in the Wolfram language, right? That's kind of one of the key feature and unique feature of the Wolfram language, of that high level of integration. So you can, from geometry, generate a graph or move from graph to image and such. So we try to actually provide that integration so that you can move from those different areas smoothly and do your computation and manipulation where is needed. And one of the new area we had, you can actually look at it as a vertical or an application of graph, is molecules. So in version 12, you introduce molecule and you can actually do a lot of operation or chemistry, using graph or looking at the structure of your molecule as a graph. So one function which was added is a constructor for graph. So molecule graph will return you the actual graph object. And you can also compute property like distances and such, right? And having all that graph functionality will allow you actually to solve, some really complex chemistry problem, right? And in this case, I kind of show how you can actually compute the shortest path between 2 atoms in a molecule. So you can just construct your graph, get the graph distance matrix, and find shortest path in it, right? And that kind of provide you all the bonds you need to traverse to reach a molecule, an atom, so in your molecule. So that's kind of an integration where we take graph and show the bridge directly from graph to molecule or molecule to graph. So something which is maybe less obvious but quite useful in this release is that we introduce, there was a whole build-up for convex optimization, right? And obviously, a lot of problem in graph can be expressed as an optimization problem. So that means essentially that those framework of convex optimization, which was added in version 12, allow you to solve some of the problem in graph networks where we don't even have new functions, or maybe your problem is unique enough, but you can formulate it as an optimization problem, right? And then you can go and solve it. So this is an example where we actually show how you can solve the max cut problem, right? If you remember, we have the min cut function. So this is kind of the opposite, the max cut, not the opposite, but the maximum. The other one is the minimization problem. Right. So you can actually use the new semi-definite optimization function in version 12 to solve that. Right. So essentially, in this case, I take a random graph. Right. You can compute the Laplacian matrix, which is essentially the weighted version of the Kirchhoff matrix we have. And based on that, you can actually essentially reformulate that MaxCom problem as a semi-optimization problem. And here we actually compute the dual value, and we use it to actually find, the cut by randomized rounding, essentially, where we decompose the resulting matrix using Cholesky decomposition. And there you actually have your result. Oops, I have a small problem here, so I probably forgot to evaluate something. So let me restart that. In my graph, that, and that, and I have my resulting cut here. So this is essentially the cut value, and that is the two cut. And you can actually apply community graph plot to look at actually the result of the cut. So the key idea to remember here is that the convex optimization is actually an extremely powerful tool you can actually use to solve your graph problem. And roughly you can solve all the optimization-based problem using that new framework, or where you can just reformulate it if you have enough knowledge of your problem. So to summarize, essentially in this feature, we modernized the visualization, added some new functionalities, new layout, new plot themes. We provided the inheritance of property to all the graph operations, and we hope to actually enhance it in the next feature release. And we get back in, for graph and networks, a lot of functionality coming from convex optimization, as well as providing more, integration to other parts of the system like molecule or entities. So that's kind of give you a general view of what we introduced in this release. So before I close, I will look if there is any additional questions. So if I look at the Twitch, well, I don't believe there is a general questions about the new functionality. So I would like to thank you for joining us for this talk, and we'll probably take a break during this August month, and we'll be back in, the usual sequence of Tuesday and Thursday on presenting the new feature of the new functionality in version 12. So right. So there is a new question. So let me look at that. A question. So are there plans to support edge property for multigraph? Yes. So that's kind of one of the requested functionality in by user. So we hope in the next coming release, we will have that support for property for multigraph. So when we release version 12, one of our focus was essentially to provide functionality for, all the graph type in general. And multigraph was one of the cases where, we needed to do a little bit more research, as well as, know exactly how user want to, play with those type of graphs, right? So similar as property inheritance, we got enough feedback, and we believe that we are ready to actually provide that functionality. So, stay tuned, and I'm sure you will actually see that in the next coming release. Well, I believe that's pretty much it. And well, If you have any additional question, feel free to email us or contact our technical support. And thank you for your time.